Hello everyone. In this video, we are starting a brand new series on Microsoft Agent Framework, which is the next big step in how we build the intelligent agents and the multi-agent application on Azure. So this first part is going to focus on the introduction. We'll go deep into what Agent Framework is, why is it created, how it evolved from Semantic Kernel and AutoGen, and what are the core building blocks that make up this framework. In the second part of this series, we'll cover the MCP, the middleware, state persistence, and knowledge integration. And then in the third part, which is the last part, we'll bring it all together with the different workflows and observability. So let's get started. Before we talk about agent framework, we need to understand where we came from. So when Azure OpenAI was first released, most of us were working directly with the SDK, and we were writing prompt. We used to send them to the model and get back the plain text information. So it was simple, but if you want to build something serious like calling APIs or maintaining the memory or coordinating multiple steps, you have to create a custom code for it. There was no structured way to build real applications. Then came the semantic kernel. Semantic kernel was Microsoft's first real attempt to make this more structured. It introduced the skills and the functions so you could wrap the APIs or code as reusable functions. Semantic kernel had planners, so the model could figure out which functions to call. Also, it supported the memory connectors, which made it possible to store the embeddings and perform the retrievals. So this was a big improvement. With semantic kernel, you could build more modular functions or the systems, but it had some limitations also. The planning system wasn't always reliable for the multi-step scenario, especially with the complex tasks. And the middleware and the security were not good enough features. And once you went beyond a single agent, it used to become messy very quickly. And then we saw the AutoGen, which gained popularity very quickly. AutoGen was amazing because it introduced the multi-agent collaboration. You could define the multiple agents, give them the different roles, and they could talk to each other to solve the task together. But here was the issue. AutoGen was community driven. It wasn't fully aligned with Azure Enterprise ecosystem. So it didn't have the strong standards for the memory, tools, or the security. And the MCP integration was not there. You can talk about the observability also. It was minimal. The enterprise found it difficult to use securely at scale. And that brings us to Microsoft Agent Framework. So the Agent Framework is the next step in this evolution. It combines the simplicity of SDK, the structured approach for semantic kernel, and the flexibility of AutoGen, but in a clean, unified, and enterprise-ready framework. So Agent Framework introduces proper agent abstractions and the tool integration, thread-based state, middleware hooks, and the workflows with executors and the edges, and even the MCP for the external tools and observability. And everything you get in one place. Think of it as the Microsoft way of saying this is how moving forward you have to build agentic systems. What exactly is Microsoft Agent Framework? So it's a developer framework for building, orchestrating, and managing the intelligent agents in a structured, scalable, and the secure way. So with it, you can create the intelligent agents that can reason and act, attach different tools and the functions that they can call, maintain the conversation state using the threads, connect to the enterprise data sources securely using the MCP, and even you can build the workflows to orchestrate the multiple agents. And the best part is you can insert the middleware for the guardrails, logging, and validation. And then you can observe, debug, and manage all these flows in the production environment. So basically, it is designed to fit naturally in the Azure AI ecosystem. We're working with Azure OpenAI, Azure AI services, and databases, APIs, and other Azure services. So before we build anything in the lab, let's get familiar with the core components of this framework. So first one is the agents. So agents are the main actors. They receive messages, reason using the models, and decide what actions to take. So threads are where the conversation history and the states are stored. For each conversation happens inside a thread, which makes the multi-turn interaction simple and reliable. Now, if we'll talk about the tools, tools are the functions or the APIs that an agent can call to get the work done. So they can be built in tools or completely custom ones you can write. And if I'll talk about the middleware, so it lets you plug in the logging, guardrails, authentication, or transformation logic around the agents and the different tools. And you don't have to modify the complete agent itself. It's just the middleware you have to change, and everything will be called through that. And you can define the different workflows gives you a way to wire the multiple agents and steps together using the executor and the edges to build the sequential branching of the parallel flows. And finally, the MCP, which is model context protocol, allows the agent to dynamically discover and use the external tool servers, for example the databases or the APIs. You don't even have to hard code them. So this modular design is what makes the agent framework clean and extensible. So now let's discuss all these components in a bit of a detail. So agent is at the heart of the framework. So you can use the built-in agents like the chat client agent for the quick setups. They can give you the fast way to get started, or you can write the custom agents if you need the more control. You can define how they process messages, handle structured output, or interact with the different tools. So the agent can run in a non-streaming mode where you get the complete response at once. And it is good for the backend where once the agent has provided all the tokens or all the information, it just provides that information. However, you can use the streaming way also, where you receive the partial tokens as they are generated. And it's perfect for the chat application or the voice bot so that you don't have to wait till the agent completes its response. So the agent can also produce the structured output like the JSON, and they are very useful when you want a predictable output for the downstream processing or the chaining with the other systems. For example, you want to set up a calendar booking system. So in that case, you have to specifically define the date and the time format so that the calendar can accept it, or Outlook 365 if I'm talking about. So in that case, you need a structured output, and using the Microsoft Agent framework, you can do. So now if I'll talk about the thread and the state, a thread is simply the conversation context. So every time an agent runs, it happens within a thread. So if you use the same thread ID for the multiple runs, the agent retains the previous message and can continue the conversation naturally. So it will have its own memory. So this is extremely powerful for multi-turn conversation. And later in the series, I will show how we can persist the threads to make conversation durable across the sessions. Now, if I'll talk about the tool and the function calling, so tools are what turn an agent from a chatbot into something really useful. An agent can call the functions that you attach in. You can attach the tools when you create the agent or dynamically at the runtime. So the model decide when to call a tool based on its schema or the conversation. So you can secure the tool using allowed tools. So the agent can only attach the approved functions. And this is very crucial for the enterprise security. This approach means that the agent isn't just responding with the text, it can fetch the data and trigger processes and interact with the system intelligently. Now, Microsoft Agent Framework provides the middleware. So, middleware gives you a clean interception points around the turns or the function calls or the model interactions. So, there are mainly three types. One is the run middleware, which wraps the entire agent run. It's useful for logging or authentication. Now another one is the function calling middleware, which is around the tool call. So it's perfect for validation and the security. And the third one is the chat client middleware, which intercepts the model calls, and it's good for tracing as well as the transformation. So instead of adding all these features into the agent directly, you can plug them in very cleanly into the middleware. And that's a huge win for maintainability. You don't have to maintain all the different components. So just add the middleware and create multiple agents, and everything will be done through that. Now, if we'll talk about the workflows, we will explore the workflow properly in the third video. But here is a quick preview of it. A workflow is like a graph of the steps. So each step is an executor, and the connections between them are called the edges. You can design the sequential flow, branching decision flow, parallel flows. This solves the orchestration problem which semantic kernel planners had and makes the multi-agent collaboration clean and manageable. Then if we'll talk about the MCP, which is Model Context Protocol, it allows the agent to connect to the external MCP servers and discover the tool dynamically. For example, instead of hard coding a SQL connector or the SQL APIs, you can expose the database through MCP, and the agent can query it securely at the runtime. And this is very important for the enterprise scenarios, because now if you have created an MCP server for the SQL, then you can create, or multiple teams can create the different agents and they can connect through the MCP server, instead of every agent has to connect to the SQL directly. And all of this, agents, threads, tools, middleware, workflows, MCP, bring us to a very simple point. Microsoft Agent Framework is not just another library, it's a unified way to build, structure, secure, and scale your agentic systems. So let's quickly recap what we have covered in this introduction: the evolution from SDK to semantic kernel to AutoGen, and finally the agent framework. So what the framework is, why it was created, the core building blocks and how they fit together, and how the agents work, how threads maintain context, how tools enable the different actions, how the middleware is in clean extension mechanism, and a quick preview of the workflows and the MCP for the next video. So now in the lab, I'll show you how to set up the multi-agent framework and create the different agent using it. So let me show you step by step. So I'm logged into Azure portal now, and to use the different model, we have to use the Azure AI Foundry. So let's quickly go to the service Azure AI Foundry and create a new Foundry. Test agent framework. Test agent framework 01, and let's east us2, and let's leave the project name as same. No changes, everything default. It's running the validation. Once the validation is done, we'll just create it. So the deployment has started now. I'll pause the video and we'll be back once it's done. So the deployment is successful now, and as you can see, hub and the project is created. So let's go to the hub and open the Azure AI Foundry portal. So as soon as you go to the hub, you can click on Azure AI Foundry portal. So we are in the Azure AI Foundry portal and you can see the project here. So we are in the first project. We didn't change the name, but you can from here. Now to create the agents using the Azure AI Agent Service, you need to deploy the model. So I have to show you different ways, which I'll provide information about soon. But let's go to the agents and just deploy the model. We'll delete the agent for now. So right now there are no agents, so automatically it will prompt us to deploy a model. As you can see, there is no agent, and now there will be a pop-up which will ask us to deploy the model. So now I'll deploy the GPT-4o model. Let's confirm it and increase the token size. Okay, and deploy. As soon as we deploy the model, it will create an agent also. So, but for now, we don't want an agent and we just want to deploy the model. So I'll just delete this agent, and right now we don't have any agent. So I'll quickly open the VS Code, and there are multiple files which I have created. And as the name suggests, these all files do what so we will create the agent using the Microsoft Agent Framework. Then we'll use the existing agent if the agent is already created. Another one is that we don't want to use the Azure AI Agent Service. We just want to use the Azure OpenAI model directly. We'll use that. And there are other tools which I'll show. So before this, there are packages which needs to be installed. So one is the agent framework. Then because we have to deal with Azure AI Agent Service or Azure AI Foundry, so we are using the Azure Identity, and then the Python.environment because we are using the environment variables file. So this is what it's doing is it's just creating, first is importing the packages, loading the environment variables, and creating the agent. So what it's doing it's first creating a new agent where you'll get a message that what agent is created, and then you can chat with that agent. It's pretty simple, pretty easy, and let's run it. So first activate the environment variable, it's activated, and then the next step is just run Python command. Oh, my bad, we haven't provided the values, so yeah, you can ignore this one for now. Vector ID store, this is not required. However, we need the AI project endpoint as well as what model we are deploying. So we have already deployed GPT-4o, but we need the AI project endpoint. So let's quickly get that information. So if you go to the overview, you can get it from here. This is the Azure AI Foundry project endpoint. So if we'll go back here, provide it, save, and let's run it again. And perfect. This time it's creating a new agent in Azure AI Foundry, and this is the assistant ID of the agent which is created. Let's quickly check if there is an agent created there. In the agents, yes, demo assistant agent is created. There are no tools attached, it's just a plain agent which is created. And then of course you can ask anything, what is machine learning, and it will provide you answer. So now using the Microsoft Agent Framework, you can easily create the agents into the Azure AI Foundry agent service also. This is going to create a new agent. So yeah, let's quickly check, because this file creates a new agent. However, there is another file which uses the existing agent. So let's go to the agents, and there are two demo assistant agent. We just want to see if it's working. What is machine learning? Time it should provide an answer. Sometimes there are issues with Azure Foundry AI agent service, so now it's working. However, the third agent is created, as you can see, with the same name, third agent, and it's working. What is machine learning? And this time it's providing answer. So basically, agent framework is creating an agent in Azure AI Foundry agent service, and then we are chatting with it. Now another option is, let's first delete this quickly. Let's delete all the agents. Let's create our own agent. We'll create agent, we'll name it as test agent. Okay, and let's copy the agent ID. So there is only one agent right now, and let's go to environment variable 02, copy it here, and I will copy the endpoint also. So because the second file uses the different environment variable file, so now we have provided the agent ID. Let's go to the file, use an existing agent quickly, and check what it's doing. So same way, it's loading the environment variables, and instead of creating a new agent, it's getting the details of that chat agent. And once it does that, you can chat with it. So let's quickly close the older one, go to 02. I will upload all this code into the GitHub, and you can find the link of the GitHub in the description of this video. Perfect. So now it connected to our assistant which we have created, the same one, and we can chat with it, and it should provide a response. Perfect, it's working. So now two scenarios we have taken. We have created a new agent from the agent framework using the agent framework. If someone has created it manually into the portal, then you can use an existing one also. So let's go to the third scenario. The Azure AI agent service has some charges attached to it, but we don't want to provide those charges, or we don't want to incur those charges. We just want to use the model directly, and by using the model we just want to chat with it or do whatever and create the agents locally using the agent framework. So in that case, we have to provide the Azure OpenAI endpoint directly for the model and the key. So let's quickly go back to our model and endpoints, and this is the GPT-4o model, and you can copy the endpoint from here and the API key. Once this is done, before that, let's quickly check what it's doing. So it's loading the environment variables for the Azure OpenAI endpoint, and then it's creating the agent using those details. However, this agent is not created in Azure AI agent service. This will be temporary local agent which is created, and you will save cost in it, because now you will not be using the tokens in Azure AI agent service. You will be just using the model tokens. So let's run this. So the agent is created. Let's quickly check if it provides answer. And perfect. Now let's confirm whether this agent is created in the Azure AI agent service or not. So if we'll go here, just now one agent is created. So because we clicked on the service, there was nothing. So let's quickly delete this. So there should be none, and run this again. What is machine learning? And it's providing the answer. However, there is no agent here. And that's perfect. So now this agent is created directly using the agent framework. Okay, this is the third scenario. Now the fourth one is the file search tool. So when you use the Azure AI agent service, you have the knowledge tool option where you can use the Azure AI search service, where the vectorization, chunking, everything happens there, and then you can search through the file, which is retrieval augmented generation. Now how can we use it? Using the function calling or the tool calling using the Microsoft agent framework. And we can do that, but for specific file search tool, we have to connect to Azure AI agent service. Now you should have the vector store created for it. So let's quickly go here. So there are two ways. One, you go to Azure AI search service, create a search service here, then go down to management center, connected resources, create a new connection, search for your service which you have created or the vector store which you have created in your service, connect it here, and it will be visible in your project. This is one way. Another one is kind of hack. You go to the agents and it will create an agent automatically if there is none. But go to the knowledge tools, click on the files, upload a local file. So I have uploaded a renter's guide for Victoria, Australia, and upload and save. So what this is doing is, because Azure AI agent service provide the managed storage account as well as the Azure AI search service. So the chunking, vectorization, embedding, everything will be done in the backend, and this will create a vector store. However, we don't want to use this agent right now. So let's delete it. So there should not be any agent. However, when we'll just go back here, come back here, it will create a new agent. But for now, there is nothing. But if we'll go to the data and indexes and the vector store, there is already a vector store which is just created. We just created it. So what we have to use here is just use the vector store ID. You can directly use it when you create the Azure AI search service, AI agent service, or Azure AI search service. But in this case, I'll just use the existing one. So go back here. Now in the environment variables file, I had commented this. That is the reason. So for the fourth scenario, we'll just provide the file, endpoint of the project, and the model which we have used. So let's check the file, what it's doing. It's importing the environment variables, it's checking the vector store ID, all those details it's getting, and then it's creating an agent. So it will create an agent, attach the tool, and then we'll run it. So let's quickly run. This one is 04, and let's check if it has created an agent. Now this didn't create the agent. Let's check if it provides answers. Yeah, it has created now actually when you first ask anything. So it created an agent. Let's delete this one. So file search bot, and when you look at the knowledge tools, a vector store is added here. So now you can ask, what is rent? Yeah, that's just stupid question. And it should get the information from the document. As you can see, it's providing the source information. Perfect. So now using the agent framework, you can create the agent in Azure AI agent service, and you can even attach the tools or do the function calling. Now another scenario where we don't want to use the Azure AI agent service. Now in that case, we can do the function calling, basic function calling. And here in this case, We have just created a function, calculator function. It's a Python function we have created, and we just want to call this when we ask any question. So let's run this. 05. And let me ask the question. And right now it hasn't created any agent, and there is already an agent. We can delete it, but still it will answer. Actually, it's because we are not using the AI, it's doing the function calling. Function calling is a Python function, so it's just doing the Python function calling. If you want to use the multiple tool calling, how we can use it using the agent framework. Now the scenario is, so there are different functions which are defined: weather function, calculator function, and time function. So when we run this, there are three different tools which are assigned, and the agent framework will decide, or the agent will decide which tool to use, so based on the type of question you use. So let's run. So the sixth one, and these are hard coded information. I'm not running the actual tool here. What is the weather in Tokyo, and what's some mathematical calculation. So it should use two different tools, and it will provide an information based on it. And it's creating a local agent. It's, and if you'll go here, there is nothing. The weather in this, and the result is this. So different tool calling. Now agent is smart enough to decide which tool to call. There are multiple tools available, and based on the question, it can call that tool. The next one is the human in the loop. You have different scenarios where you create an agent, and agent has to decide something, but we have created autonomous agent, and in the enterprise scenarios we don't want to use them. We need human in the loop for approvals. That's what we are going to test here. There are two functions which are defined. Function calling is happening, however there is a human approval which is required. There are two functions. First, approval required tool which is created, so it will call that tool based on the requirement. There are two functions which are created. One is create file, no approval here, it will just create a basic file here. And another one is the delete file. However, in this case the tool calling will happen that approval is required, approval callback, and then you have to run it. So let's run the file 07. I've just provided this so that it's easy to test, and it should be able to create a file. Yep, test file created. So if we'll go to the demo, there's a test file which is created with some content. Now let's delete the test file. It will ask for the approval action. So if you'll just write yes, so that means you have to provide your inputs or approve it. So once it's done, the file is deleted. Let's check if it has really deleted. Yes, it has. So now the agent framework can make the agents to go through the approval phase, where the agents are autonomous, but however, if there is certain approval that has to be taken, then human in the loop is required. And the last one is the structured output, which is really important. As I've already mentioned, there are certain scenarios. For example, you have attached the calendar tool, and the calendar requires a very specific format, the date and time in specific format, and then minutes, hours, and all those, how it should be. So if you don't provide that format, it will not work. So that for this is really important. Now we are directly using the model. The agent is created locally, not in Azure AI agent service, and it's just providing some basic information in a specific format, structured format. It's just personal information, it has to provide it in a structured way. Let's run this. 08. I will write a question. This is Michael, age 35, software engineer from San Francisco. Now think of a scenario where you have to uh, where you have a tool which is a Microsoft form. So a person has been chatting, and then all the details of that person you have to capture and fill out the form and send the form to required authorities who are running this agent. So in that scenario, either you ask one question at a time, or if there is no structure, like the user is just normal chatting, in that case that information can be easily fetched. And when you run this, so it's extracting the structured data, and it will provide the data in a specific structure like name, age, occupation, city. So this makes it easy. When the agents provide in a structured way, it makes it easy to use them somewhere, and it can get you can get in the JSON format or a specific format which is required by the different tools, or if you have to fill out some other information, then you can do that. So that's all I wanted to show in this video. In the next video, we'll get the hands-on on MCP server, the middleware, state persistent, and the knowledge integration. You will see how agents connect to enterprise data, apply the guardrails, and remember the information and retrieve the knowledge intelligently. And in the final part, we will build a complex application for production and then add the observability. And specifically, we'll use the different workflows there and run the real end-to-end multi-agent framework scenarios. So that's all I wanted to show, and I hope you liked it. Please like and subscribe. Thank you so much.